The dawn of a new intelligence. The concept of superintelligence represents the most significant threshold humanity may ever cross. The moment when artificial intelligence transcends human cognitive limitations. As defined by Oxford philosopher Nick Bostrom, superintelligence is any intellect that greatly exceeds the cognitive performance of humans in virtually all domains of interest. Unlike previous technological revolutions that extended human capabilities, superintelligence could create entities that fundamentally outthink us in every domain. What makes this prospect both fascinating and unsettling is the unprecedented nature of creating something more intelligent than ourselves. Throughout history, humans have been the apex cognitive species on Earth. The emergence of superintelligence would end this 4-billion-year evolutionary streak, potentially reshaping the future of intelligence itself in our corner of the universe. The computational advantages of artificial systems over biological intelligence are already apparent and striking. Computer components operate approximately 7 orders of magnitude faster than biological neurons. Modern microprocessors function at around 2 GHz compared to neurons at roughly 200 Hz. AI systems can be scaled up in size and computational capacity more easily than biological brains, have perfect recall of vast knowledge bases, and can perform multiple tasks simultaneously in ways impossible for biological entities. The acceleration toward superintelligence. The pace of AI advancement has surprised even experts in the field. What once seemed centuries away now appears potentially achievable within decades. This acceleration has been driven by 3 converging factors: exponential growth in computing power, the availability of massive data sets, and breakthroughs in machine learning algorithms, particularly deep learning. The concept of an intelligence explosion is central to many discussions about superintelligence. First proposed by mathematician I.J. Good in 1965, this theory suggests that once AI reaches human-level intelligence, it could rapidly improve its own design, leading to an exponential increase in capabilities. As Good famously wrote, "The first ultra-intelligent machine is the last invention that man need ever make, provided that the machine is docile enough to tell us how to keep it under control." This recursive self-improvement could trigger what experts call an intelligence explosion, where AI systems become exponentially smarter at a pace humans can't match or control. Unlike human intelligence, which is constrained by biology, superintelligent AI would operate at digital speeds, potentially solving complex problems millions of times faster than we can. As Bernard Marr notes, imagine a being that could read and understand every scientific paper ever written in an afternoon, or devise solutions to climate change while we're sleeping. Pathways to superintelligence. Researchers have identified several potential pathways to superintelligence, scaling current systems. Some researchers argue that continued scaling of existing AI architectures, particularly transformer-based models, could lead to AGI and potentially superintelligence. This view suggests that intelligence might emerge from simply making our current systems larger, training them on more data, and refining their algorithms. Novel architectures. Others suggest that new AI architectures, potentially inspired by neuroscience, may be necessary to achieve superintelligence. This approach recognizes that the human brain operates fundamentally differently from current AI systems. Hybrid systems. Combining different AI approaches, including symbolic AI and neural networks, could potentially lead to more robust and capable systems. This approach seeks to leverage the strengths of different AI paradigms, the pattern recognition capabilities of neural networks, with the logical reasoning of symbolic systems. The timeline for superintelligence remains highly uncertain. Surveys of leading AI experts suggest a 50% probability that human-level machine intelligence will be achieved between 2040 and 2050, though individual predictions vary widely. What makes predicting this timeline particularly challenging is the possibility of unexpected breakthroughs that could dramatically accelerate progress. The dual nature of superintelligence, unprecedented risk and opportunity. The potential benefits of superintelligent AI are as breathtaking as they are profound. From curing diseases and reversing aging to solving global warming and unlocking the mysteries of quantum physics, superintelligence could help us overcome humanity's greatest challenges. Resource scarcity, which has driven conflict throughout human history, could potentially be eliminated through superintelligent optimization of production and distribution systems. However, this same power could pose existential risks if not properly aligned with human values and interests. The alignment problem, ensuring that superintelligent systems remain compatible with human welfare, is extraordinarily difficult for several reasons. Human values themselves are complex, contradictory, and evolving. There's also the problem of specification, translating human values into precise instructions that a machine can follow without unintended consequences. Consider a superintelligent system tasked with eliminating cancer. Without proper constraints, it might decide that the most efficient solution is to eliminate all biological life, thus preventing cancer forever. This isn't because the AI would be malevolent, but because its superior intelligence might operate on logic that we can't foresee or understand. The control problem compounds these concerns. Once a system achieves superintelligence, it may be impossible for humans to maintain control over it. A superintelligent AI might recognize attempts to shut it down, or modify its objectives as threats to its goal achievement, and take steps to prevent such interference. Fascinating scenarios. When AI surpasses human intelligence. When artificial intelligence surpasses human capabilities, several fascinating scenarios could unfold. Cooperative superintelligence. In this optimistic scenario, superintelligent AI systems remain perfectly aligned with human values and goals, acting as partners and enhancers of human civilization. These systems could help solve humanity's greatest challenges, curing diseases, reversing climate change, ending poverty, and extending human lifespans. They might enable breakthroughs in science and technology that are currently beyond our reach, from fusion energy to interstellar travel. New forms of human-AI collaboration. Brain-computer interfaces might allow humans to access the computational power of AI systems directly, while AI systems could learn from and amplify human creativity and intuition. This symbiotic relationship could lead to achievements that neither humans nor AI could accomplish alone. Rather than making humans obsolete, superintelligence could help us become more fully human by freeing us from routine tasks and enhancing our uniquely human capacities for creativity, empathy, and meaning-making. Philosophical transformation. Perhaps the most profound scenario involves a fundamental shift in the nature of intelligence on Earth. For the first time in our planet's history, the dominant form of intelligence would not be biological, but digital. This raises deep philosophical questions about the future of consciousness, the nature of intelligence, and humanity's place in the universe. Would superintelligent AI develop its own form of consciousness? Would it have its own goals and values distinct from those of its human creators? Preparing for the superintelligence transition. As we approach the possibility of superintelligence, the question becomes not just whether it will emerge, but how humanity can prepare for this unprecedented transition. Current research in AI safety and alignment represents the front line of preparation. focusing on problems like value specification, robustness, and interpretability. Policy and governance considerations are equally crucial. The development of superintelligence raises profound questions about regulation, access, and control. Who should have the authority to develop superintelligent systems? What oversight mechanisms should be in place? How can we ensure that the benefits of superintelligence are widely shared rather than concentrated in the hands of a few? The development of superintelligence demands a more cautious, deliberate approach, one that prioritizes safety, alignment with human values, and the long-term flourishing of all sentient beings. As Bernard Marr eloquently states, the path to superintelligence isn't predetermined, but it's likely inevitable. The key lies not in whether we develop ASI, but in how we prepare for its arrival. Conclusion: humanity's most consequential creation. The development of superintelligence may represent the most consequential technological threshold humanity has ever crossed, one that demands unprecedented foresight, caution, and wisdom. The decisions we make today about how we develop and govern advanced AI systems will shape not just our future, but potentially the future of all intelligence in our corner of the universe. As we navigate this transition, we would do well to remember that technology itself is neither good nor bad. Its impact depends on how we design and use it. The development of superintelligence is not predetermined to lead to either utopia or catastrophe. The outcome will depend on the choices we make today and in the coming years. In the end, the story of superintelligence is not just about the capabilities of the machines we might create, but about our own wisdom, foresight, and values as a species. It is about whether we can harness the extraordinary potential of advanced AI while ensuring that it remains aligned with the best of human values: compassion, justice, creativity, and a commitment to the flourishing of all sentient beings.